Hello everyone, welcome to my LaTeX tutorial. In this tutorial, we'll go over what is LaTeX, how to install it, and we'll go over some basic building blocks so you can write a simple lab report. LaTeX is a what you see is what you mean typesetting software. That means that um, the letters you type on the page don't necessarily show up. You're typing a computer code that um, the LaTeX compiler will compile into a document. It is widely used in research and academia. To use LaTeX, you will need a text editor of some sort. It could be Notepad, Vim, or Emacs. You need a compiler engine, which I'll show you how to install, and a document viewer to view your document, which is usually a PDF, but sometimes it can also be HTML. So that could be any PDF viewer or even your web browser. So LaTeX has many benefits. It separates the writing from formatting, which makes um, the it allows the writer to focus on the writing and then format the document after the fact. Since it's in plain text, it's very easy to copy, and the compiler will do all the formatting itself. It has features such as automatic citations and footnotes, has a very extensive math syntax, which is why academia loves it so much. It's saved as a plain text document, which means it's very small, and you can also use command line utilities to edit and view it without even opening up your text editor. Certain academic journals require you to submit a uh, LaTeX document for your article. So if you want to pursue a career in research, you might as well start learning now. And it can produce any document from research papers to textbooks to sheet music. And when other students are walking by you, you look pretty cool working on LaTeX. They think you're some pro coder, but as you'll find out in this tutorial, it's actually pretty straightforward and intuitive. So there's offline editors and online editors. If you should install the one depending on your operating system, and if you want to skip the installation, you can always use a online editor. However, if you don't have internet where you're working, not likely to be the case nowadays, but should that be the case, you'll not have access to your documents if you're using an online one. So I do recommend using an offline editor. So if you're on Windows, you can install MikTeX. Go to their download page, hit the download, and install it. If you're on Mac, use MacTeX. Same thing. Hit the download button, smaller download. Click here and go through the download process. Uh, MikTeX and MacTeX, to my understanding, I've never used them before, but they should come with their own text editor GUI with auto compile, so that might make things easier. And lastly, if you're using Linux, you should use TechLive. It's yeah, it should be available in most of your most Linux repositories. I'm using Arch. It's definitely available here. And if you want to skip the installation process altogether, just go on Overleaf, make an account, and get started. Alrighty, so I have here a LaTeX tutorial directory. If we list it, we can see that we have a test document. And so we can just go in vim test.tech. We're just gonna delete all of this. So to make a document, you'll need 3 lines of code. It's quite simple. So first you need document class, article. This just tells it it's an article. There's many different other formats such as books, but article is the most commonly used one. And then begin end. We will have document. Then we can just start typing. So hello world. So if we write this and compile it, you can see here's our document. Hello world. Very nice. I'm gonna shift this over a bit. Okay, so the first thing in your lab report you're probably gonna need is title. So title, LaTeX showcase, and you probably want your name on that. So author Benson, which is my name. So if we write this, we can see it blinked, so it means it did recompile, but nothing happened. So why is that? Well, that's because you see, this is the begin and end document. This is the document environment, right? So everything that you see on the page needs to be between the begin and end. So what we can do is just have the make title command here. And now, boom, look at that. LaTeX Showcase by Benson, and it also gives you the date, which you can change or remove, which I'll show you in a later tutorial. All right, so at the start of your lab report, you probably want an abstract, so that's just abstract, and then let's say this document showcases how to use LaTeX. So there's our abstract here. This document shows how to use LaTeX. The abstract is very nice because it automatically centers it in the page for you, which is what most research papers want you to do. In your lab report, you want sections, subsections, and sometimes, depending on the size, you probably even want subsections. So this is just backslash section. This is a section. And then subsection. This is a subsection. And a, oh no, this is just a subsection. There you go. And then subsection. This is a subsection. Right. And you see, this is a section, this is a subsection, this is a subsection. As you can see, I never typed any numbers, but the compiler adds the numbers for you. Now, if you like numbers, you can keep it as is. If you want a different format, or if you don't want numbers at all, you can always change that, which I'll go over in a separate video. This is just showcasing the basic building blocks so you can get a lab report on the page. So we're going to next go over how paragraphs are structured and how LaTeX reads your code. So this is all on one line. So you can see if we have everything one line apart, it will read it as all on one line. However, if we do this is another line, if you have two spaces apart, it will treat it as a separate paragraph. This is very useful. For example, if you're typing up really long equations, you can have each term, for example, on a separate line to help you with readability on the source code side, but your document will still have the equation all on one line. Next up, I'll show you how to use a table to insert a table here. So we're gonna harpoon this. Let's see. So delete this. We're gonna find. In my LaTeX tutorial, I have here a table1.csv. This is just a random set of data I got from one of my labs. So table1.csv. So we're just gonna copy all of this. back. To make a table, you will need the tabular environment, tabular. Oh, whoops, begin, end, tabular. And we can just paste our data here. And since it has 3 columns, as you can see, we have a time, displacement, and velocity column. We will need to tell it that it has 3 columns. So how we do that is we can do CCC. This tells LaTeX how to align the columns, so you can also have like left and right, center. Those are just the basics. There's, I think, a couple more, but left, right, center should be enough. You can read the documentation more. And so if we try to compile this, you can see that it gives us an error. That's because LaTeX does not use commas to separate the uh, the different items in your table. So we're just going to do a quick, gonna get rid of this. Gonna do a quick substitute command. So we'll do substitute, do global substitute, comma, into, and do that globally. Whoops, we're gonna go back actually. Gonna have spaces between them. There you go. And we also, so if we compile this, we can see that it's also not working. That's because for each new line, we also need to add backslashes. So what we can do is do append backslash, then we can just use there, use some Vim magic to get that done. So now we can see that our table is looking fairly nice. Not really. To make lines on the table, if you want to make vertical lines, you can do this through the column editor. So we can add pipes, the pipe symbol here. This will add lines to the sides, and if we want them in between the columns, add them in between the columns, like so. And then for horizontal lines, we can simply just type the command hline for horizontal lines. So just make our table look nice. Hline. Can I do this? Nice. Okay. So now we have a decently looking table, but your table needs a caption, right? So LaTeX has a separate thing for captions. So we will do a begin and table. What we'll do is we can just paste this in here. And so now the tabular environment is in the table environment. Now the table environment tells LaTeX that, hey, this thing right here, it's a table. So then when you put a caption on it, it'll say table 1 instead of, say, figure 1 or graph 1. So we can just say caption. And we'll say time versus spent versus velocity. Really awful caption. You'll definitely get a 0 for this if you write it like that. But here is our table. So time versus displacement versus velocity. So now you can notice it kind of flew to the bottom of the page here. If you just leave it normally, LaTeX will just place the table where it thinks it's the best fit. And also the table is off center. So to fix this, the off centering part, it's quite simple. We can just give it the centering. And now the table is centered. And if if we want to put the table about where we wrote it, where on the document, we can go to the table environment here, give it square brackets and give it H. This will tell it, hey LaTeX, like please put this table about where I have it in the code. So now you can see it is about where I have it. Now this doesn't always work depending on how you have your document structured. Sometimes if the table gets cut off halfway through the page, LaTeX will say, okay, I'm not cutting off the table halfway. I'm going to put it on a new page. So you gotta kind of just work with it. Sometimes you can also add the exclamation mark to tell it, hey, put this exactly here. Screw your formatting rules. But even that, sometimes depending on how your document is structured, doesn't always work. So yes, structure your documents correctly. Don't force LaTeX to cut your table in half because it really doesn't like doing that. And to do that, you'll need special packages for it, which yeah, we'll go over in another video. So we have our table here. Now next, we will go over some lists. So you might want a list for your apparatus or sometimes for your procedure. I don't think they want it for the procedure, but yeah, for your list of apparatus, you definitely want a list. So we'll do begin end, which brings an environment. Now, depending on if you want a numbered or unnumbered list, it's either itemize or enumerate. So if we want a unnumbered list, we can do itemize. And to add items to the list, to tell it it's an item, we can simply type item. So we'll just say apples, bananas, and oranges. So itemize unnumbered list, you can see their bullet points. So apples, bananas, oranges. If we, however, want it to be numbered, we can we'll paste this again, and then we'll do a fancy substitute command. So from 56 to 60, substitute itemize with enumerate. Yeah, I think I spelled that correctly. Whoops. Okay, so our second list here, you can see with the enumerate command is 1, 2, 3 instead of bullet points. So enumerate is numbered list, itemize is unnumbered lists. All right, next we'll briefly go over how to write math. So math, there is line mode and display mode. So for example, if you're in your background and you're talking about, say, a variable, right? So we can say like the error of, and then with math, it's two $signs. We can say like, we can say delta S, the error of S is 0.01, right, for example. So you can say the error of delta S is 0.01. So in math mode, you can have Greek letters and various other symbols. I'll go over this in detail in another video. And say if you want to have an equation, right, we can use the display mode. So display mode, it'll have things centered. And this is a good way to do it. So you'll just do backslash, open square bracket, backslash, close square bracket. So we can say like y equals x squared. And yeah, there's our equation in display mode. Now, sometimes you want your equations to be numbered, right? So to do this, we do begin end equation. And with the begin end equation, you're in math mode, so we can say like 3x plus 2 equals y, for example. And now our equation here is numbered. Now the nice thing about this is that you can put this as a label. So label as, we can label this as E1. So now if we want to refer to this in a text, we can say like, for example, an equation, we can say reference E1, blah, 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 blah. So in equation 1, blah, blah. Now, why would you want to do this, right? This seems a little extra work. You gotta label it and then put it here. Why can't I just put a 1 and be done with? Just remember that this equation is number 1 and be done with it. Well, when you get into larger documents, so for example, if I put a second equation here, we'll just paste this in here. Oh, whoops. Paste this in here. For example, if we number our second equation, oh, I can't spell. That's why. Equation QU. So with our second equation here, you can see now, because this equation came before, this now becomes number 1, this becomes now number 2, and I didn't need to change a thing, and now it's still referencing this equation, but now it automatically changes it to 2. With larger documents where you have many, many equations, and perhaps during the editing phase, your supervisor wants you to, hey, I think you should shuffle things around here and do things this way, for example, you can move things around quite easily without needing to change all the numbers, right? Which is if you just type 1, you'll have to remember every time you've referenced that equation and then go change it, which could be a huge hassle that LaTeX does automatically for you, which is very nice. And lastly, I'll show you how to insert a image. So for example, you might want to insert an image of your apparatus or a graph. So in my directory here, I have this image of lane, which I would like to insert into my document. So it's lane.jpg. So we'll go to the top here. To insert an image, we will use the package. So use package, and it's called graphics. Okay, and then we will use the \include graphics, and we will give it lane.jpg. So here is our image. However, it is quite small, right? If this was your graph, for example, you're not going to be able to read that. So in order to set the size of your page, what you want to do is you want to add square brackets. This sets the options for any function, and we can type width equals, and how long do we want this to be? I don't know. Let's say 4 inches. So there you go. This thing is now 4 inches. Very nice. However, you might not know the exact size you want your image to be, right? You're not gonna print the paper off, take a ruler to your paper to figure out exactly how wide you want your graph to be. That's a pain, right? So we can say column width. Did I spell something wrong? Column. Yeah, there shouldn't be a M here. Column width. So now this is the width of the column, or yeah, so this will span from your left margin to your right margin. Now, if you don't want your graph to be that wide, you can always give it a percent, right? So if we want it half the column width, we can say 0.5 column width. And now it is half. And I believe if you want it centered, you can just do centering as well. No, you can't. So to center something, we can also use the begin, end, center. So now this is centered on the page, as you can see, and 1/2 the width. If we want it 75, we can also change it to 75. So that's the include graphics. But if you want to, for example, um, label and put a caption on your graph, we will need the begin and let's do figure. This will tell LaTeX that your this thing is in fact a figure, and we can say caption picture lane, and then we can also give it the centering command. And once again, you see, because it recognizes it as a figure, it'll fly to wherever LaTeX feels like putting it, which is usually the top or the bottom of the page. So to fix that, once again, we'll just square brackets H. And now it's back to where it is relative to the source code of the document. Oh, and also with figures and tables, you can also put the label on here and refer to them in text the same way. So with these tools of making sections, tables, lists, paragraphs, and basic equations, you should be able to type up relatively professional looking lab report. In the next couple of videos, we will go over some more finer details on each and every one of these topics. But until then, see ya.